Now I am going to explain about numerical problems on transformer. Now see here, a 200 by 50 volts, 50 Hz single phase transformer is connected to a 200 volts, 50 Hz supply. That means primary side it is connected. Okay, with secondary is open circuited. Open. Okay, primary winding has 400 turns. Okay, what is the first bit? What is the value of maximum flux through the core? That means we need to calculate flux phi m. Okay, next second bit, what is the value of peak flux? Peak is nothing but again same flux, maximum flux. If the primary voltage is 200 volts, voltage is same, frequency is 25 Hz. That means frequency 50 Hz is reduced to 25 Hz. Okay, first write the given data. What is given? The nameplate details is nothing but E1 by E2, right? E1 is equals to 200 volts, that is equals to V1. E2 is equals to 50 volts, that is equals to V2. Supply frequency F is equals to 50 Hz, right? After that, number of turns, primary turns N1 is equals to 400 turns. Okay, already we know the value of E1, E2, N1, right? Then I can use formula E1 by E2 is equals to N1 by N2 over R. E1 is equals to 4.44 F into N1 into phi m. Okay, here E1 value is known, N1 value is known, right? Then I can calculate flux phi m. Then phi m is equals to E1 by 4.44 F into N1, right? Then E1 phi m value will be 0.002 Webers after simplification. Okay, after that I need to calculate what is the value of peak flux. Same formula I need to calculate. Phi m is changes to phi m dash. Okay, induced EMF will be same, but only that term will be frequency is changed. I am indicating E1 is equals to 4.44 F dash into N1 into phi m dash. Okay, with change in frequency, what is the change of flux here? I need to calculate that flux. Then phi m dash is equals to E1 by 4.44 F dash into N1, that is equals to E1 value is 200 divided by 4.44, frequency reduced to 25 into N1 will be again same turns 400. Then I will get phi m dash value as 1 by 4.44 into 50, that value will be 0.04 Webers. Okay, in this way we can solve this problem. Okay, next problem. Okay, the EMF per turn of a single phase by 2200 by 200 volts, 50 Hz transformer is 12 volts. Okay, calculate first bit the number of primary and secondary turns. Okay, second bit net cross sectional area of core for a maximum flux density. That means B maximum is given directly, that value as 1.5 Tesla. Okay, what is given? E1 by E2 value. E1 value is given and E2 value is given, right? E1 is 2200 volts, E2 is 220 volts, supply frequency is 50 Hz. Okay, the EMF per turn is nothing but E1 by N1 or E2 by N2. That value is how much? The EMF per turn of a single phase 2200 by 200 volts, 50 Hz transformer is 12 volts. That is E1 by N1, that is equals to E2 by N2, that is equals to 12, right? Already we know E1 and E2 values, right? From this equation N1 is equals to E1 by 12. Then I will get N1 as 183 tons. Similarly E2 by N2 is equals to 12. From that equation N2 is equals to 220 by 12. We will get 18 tons, right? Okay, what is the second bit? Here I need to calculate net cross sectional area of core for a maximum flux density. B maximum is given, right? Okay, what is the value of V maximum? 1.5 Tesla, right? Then induced EMF equation of a transformer is E1 is equals to 4.44 F into N1 into Bm into An, right? F value is known, N1 value is known, right? Bm value is known. Here E1 value is also known. Directly substitute here. An is equals to E1 by 4.44 F into N1 into Bm, right? That is equals to 2200 divided by 4.44 into 50 into 183 into 1.5. Then I will get An value as 0.03 meter square. Okay, similarly last problem, a single phase transformer with 50 Hz. Okay, that means frequency is given, has area of cross section 0.036 meter square. The permissible maximum flux density in the core is 1 Weber per meter square. That means area is given, B maximum is given, frequency is given. Calculate the number of turns per limb on the high voltage and low voltage side for a 3300 by 220 volts ratio, right? That means what is given? E1 value is given. E1 is 3000 volts. E2 is equals to 220 volts, right? Okay, from this given data. Next, frequency F is given 50 Hz. Next, area of cross section AN is given, right? AN is 0.036 meter square. After that, B maximum is given, right? 1 Weber per meter square. Already we know that EMF equation of a transformer will be 4.44 F into N1 into 5M is nothing but BM into AN, right? See here, F value is known, BM value is known, AN value is known, E1 value is known, right, from this given equation. Okay, then I can easily calculate number of turns on primary limb and secondary limb. That means from this equation first calculate N1. Okay, similarly E2 is equals to 4.44 F into N2 into BM into AN, right? From that equation you can calculate N2 value. Okay, in this way you can solve the problems. Okay, thank you all.